Hey guys, in this lesson we're going to look at how to solve systems of equations using the elimination method. So yesterday we looked at how to solve with substitution. And we were able to do that with equations that were set up in either both in slope-intercept form or one slope-intercept form and one standard form, or even a situation where we had one that was solved for x or one that was solved for y, and we just wanted to be able to use that for substitution. Today we're going to look at another algebraic method called elimination that is used when we have two equations that are both in standard form, and allows us to eliminate one of the variables, meaning get rid of one of the variables, so that we can then solve for the other one. So by the end of this, you'll be able to, solve a system of equations by eliminating one variable and combining the equations together. All right, so let's get into this. So elimination method involves eliminating one variable and combining the equations to solve for the other one. This is best used when both equations are in standard form, meaning ax plus by equals c. If they're not in that form, but you still want to use elimination to solve them, you're going to have to rearrange them so they are both in standard form. You cannot do elimination unless your equations are in standard form. So here's how we do it. And it's going to sound a little bit complicated at first, but once you see it and get the hang of it, it really is, for a lot of people, easier than the substitution method. So the first thing you're going to do is stack the equations so that the ax, the by, and the c terms line up. So you're going to write one equation above another equation, making sure that the x's are all aligned, the y's are all aligned, and the constant terms are aligned. If you have it in correct standard form, they're going to do that, but you may have to rearrange it if they're not already in that form to be able to make that happen. Then you're going to look at the equations that you have to try to figure out which variable you're going to be able to eliminate. To be able to do elimination, you have to be able to cancel out one of the variables or one of the like terms by having them either be exactly the same or exact opposites. So you're going to look for two like terms, meaning either two x's or two y's, that are either exactly the same or exact opposites. So what I mean by exactly the same would be something like 2x with a 2x. Those are the same. Exact opposites would be like 2x with negative 2x. Those are exact opposites, but they're still like terms. So then you have to figure out, once you've identified that, that's going to be the term that gets eliminated. So then you have to figure out whether you need to add or subtract the equations so that the like term is eliminated or canceled. So let's talk about what happens when we have opposites. So if you have opposites like 2x with a negative 2x, think about what happens when you add a 2 with a negative 2. 2 plus negative 2 becomes 0x. That's what we need to happen because a 0x goes away. 0 times anything is just 0 and has no value. So when the terms are opposites, we add to do our elimination. Now think about what happens when they're the same. If we have a 2x and a 2x, well, if I add that, 2x plus 2x is 4x. That's not going to go away. But if I subtract 2x and 2x, that will go away. That becomes 0. And that allows me to get rid of the terms when they're the same. So when they're the same, we subtract. For you folks that like alliteration, same and subtract both start with S. That's helpful. So once you get one of your variables eliminated, then we go and solve for the remaining variable. That's going to leave you with a one-step equation. You're probably going to solve it with division. Once you know the value of that variable, you'll know one of them. You still have to go back and find the other because the answer to a system of equations has to be an x and a y coordinate. So you've got to be able to find both the x and the y to be able to give that. So we use the answer from step 4, that value that you got when you solved it, to substitute and find the value of the other variable. Again, this sounds kind of complicated, but once you get into it and you actually start doing it, you'll realize that it really is not that bad, not very scary. All right, let's get into this, some examples of this. So looking at this example right here, first thing we have to do is look at the problem and decide what we can eliminate and what operation we're going to use to do it. So we look at it and we say, okay, if I've got the same x or the same y, or do I have opposite x's or opposite y's? When I look at my x values here, notice that the x's are opposite of each other. We have a positive 4 and a negative 4. That's going to be the term that I can eliminate. I can't eliminate the y's the way this is currently written because one's a 2 and one's a 8. That doesn't eliminate. But a 4 and a negative 4 can be canceled out. So I'm going to eliminate the x term. And I'm going to do that using which operation? Remember, we have two options. We have addition and subtraction. So eliminate x. When they're the same, we subtract. When they're opposites, we add. So when I look at what I have here, I have opposites. So I'm going to add because they're opposites. So I'm eliminating this with addition. Here's how that looks. So negative 4x plus 4x cancels. I'm going to combine everything down the equations, by the way. So now when I go to the next one, I've got to read this minus in front of the 2 like a negative. So I do negative 2 plus 8, which gives me a positive 6y. And then I do negative 12 plus negative 24 gives me negative 36. If you're not friends with integers, that's okay. Just use a calculator. And so now I'm left with this cute little one-step equation that all I have to do to finish it is divide both sides by 6. So that means that my y is going to equal negative 6 because negative 36 divided by 6 is negative 6. So negative 6 is the y value. Now step 2 is a little bit tougher because now we have to take one of the two original equations, substitute that negative 6 back into it, and solve for the other variable. It does not matter which equation you choose. I always choose the one that looks like it's going to be the easiest to me, but either one will work. So if I choose one equation and you choose a different equation and you plug this in and you solve it correctly, we're still going to get the same answer. So in my mind, the second equation up there is a little easier than the first because the first one's full of negatives and the second one is not. So I'm going to go with that second equation, 4x plus 8y equals negative 24. And so I'm going to take the y out and I'm going to put the negative 6 in that spot because that negative 6 is the thing that y is equal to. So I'm going to put negative 6 in right there. So I'm taking out the y, replacing it with negative 6. Notice that I'm leaving the 8. I'm just taking the y. And then we're going to solve that. So that's just a normal equation to solve it. We're going to start by multiplying. So I have 4x comes down. 8 times negative 6 is negative 48. This side's still negative 24. And then we can add the 48 because that's the inverse of the subtraction. Negative 24 plus 48 is positive 24. I didn't really give y'all enough room for this. I apologize. And then we divide both sides by 4. And so x will equal 6. So again, we've got to be able to do the elimination with the first step and then substitute back in to solve for the second variable in the second step. Second step for this is harder than the first step, honestly, because you're having to figure out or you're having to do all the work to solve that equation. But you should be very good at solving equations. You've been doing that since the 7th grade, so you've had a couple of years practice and all of that. All right, moving on. Okay, look at this next one. So we have x minus y equals 11 and 2x plus y equals 19. Again, we need to start by identifying what we will eliminate, what matches, if anything. And so here, hopefully you notice that you have a negative y and a positive y. Those match. They have the same variable, same coefficient, but different signs, and that's okay. Which means we're going to eliminate y this time. Our x's don't match. They're a 1 and a 2, so that's not okay. And so because I have opposites, negative and positive, when we have opposites, we're going to add to do our elimination. So we're going to add because they're opposites. So I'm going to add everything straight down. So remember, an x by itself is a 1. So 1 plus 2 makes 3x. Negative y plus y becomes 0. 11 plus 19 is 30. And then we can finish this out by dividing both sides by 3. So that means that x equals 10. All right, so now let's see what we get for y. Again, you're picking one of the two original equations. Does not matter which one you choose. And you're plugging the 10 in for x and solving for y. I'm going to just use the bottom one. So 2x plus y equals 19. Again, x is 10. So I'm going to take the x out, replace it with 10. And I'm going to solve that. So 2 times 10 is 20 plus y. Then I'll subtract 20 from both sides. And that leaves me with y equals negative 1. So my solution to this is 10, negative 1. All right, continuing on. What about this one? Looking at that one, what matches in this equation? Or this system. We have 8x plus y equals negative 16. Negative 3x plus y equals negative 5. Hopefully from that you recognize that the y's match. The y's will be the piece that we can eliminate. So this time they match and they're the same. Notice that they're both a positive y. They're not opposites this time, they're the same. So because they're the same, we're going to subtract to eliminate. So I'm going to subtract down the page this time. You want to be careful when you have to do the subtraction because especially when there are negative numbers involved, people have a hard time with subtraction with negative numbers. So if you need to use a calculator, use a calculator. But you'll do like 8 minus negative 3. 8 minus a negative 3 is a positive 11. Because those two, the minus and the negative, offset each other. And so then when we do negative 16 minus negative 5, that's going to become negative 11. Subtracting the negative is the same thing as adding. All right, and then we finish it with division. And x will equal negative 1. And again, I've got to go back and get y. Doesn't matter which one you plug into. I'm going to plug into the top this time. 8x plus y equals negative 16. This time I'm going to take the x out because I know x is equal to negative 1. Replace it with negative 1. And solve that. And so I'm adding 8 to both sides. I get negative 8. All right, continuing on. Take a look at this one. Which variable can we eliminate this time? Right, we're going to eliminate the x. So they're the same, which means I can eliminate them through subtraction. That's right, same. We subtract. So I'm going to subtract the system. Negative 6 minus negative 6 cancels out. Positive 6 minus positive 3 becomes positive 3. Positive 6 minus negative 12 becomes positive 18. Again, if you're not great with integers, check it in your calculator. Divide both sides by 3, and y will equal 6. Once I know what y is, I can go back and find x. I'm just going to plug into the top equation again. Negative 6x plus 6y equals 6. There's a lot of 6's in that already. And so because y equals 6, I'm going to take the y out, and I'll replace it with 6 as well. All right, and then we're going to calculate that, or solve that. So 6 times 6 is 36. Then we can subtract our 36. And divide by negative 6. So x will equal 5. Big thing to note for questions like this, like on your test, obviously on ones that you are asked to solve on the actual test, you can put them in a graphing calculator probably and solve them. However, on questions that ask you about the process, there are a lot of questions that are going to ask you about the process of elimination. And the things they may ask you about are, if you were going to eliminate this, what variable would you eliminate? If you were going to use elimination to solve this, would you use addition or subtraction? If you use elimination to solve this, what equation would you get as a result? Those are the kinds of things you'll be asked. So that's the kind of stuff you want to make sure you're understanding about this lesson. All right, take a minute and try this one and the next one. And then when you get done, or pause the video, I'm sorry, I should have said that first. Pause the video, take a couple minutes to try this one and the next one. When you get done, come back to the video, unpause it, and then check your answers and see if you're right. But take the time to actually try to work them yourself to see if you can come up with the same stuff that I came up with. That way you'll know if you understand exactly what you're doing or not. So take a minute, pause the video, take care of that, and then come back. All right, take a look and see if you ended up with the same answer of -1 that I got. You should have eliminated your x's through addition, and then would have left you with a 9y and a -9. Finish that out and get -1. Then you can see how I plugged that in and solved for the x after that. Okay, if you made a mistake in that somewhere, if you'll pause the video again, take a minute and look at all that, hopefully you'll be able to see maybe what you messed up on and be able to go from there to fix it. And then on the next one, you should have gotten 6 -9. Again, we're eliminating the y, but this time with subtraction because they were the same. And so we did that. We ended up with a -1x and a -6. And so when you divide that out, you get a +6 for your x. Sub that back in, you end up with a -9 for your y when you finish that out. Okay, hopefully that went well for you. Now we need to look at situations where, what if we're given a system and they don't have matching pieces? What do we do? So, y's match. When you can't eliminate a variable the way that it's written, you're going to have to change the system to create something equivalent that will be able to do elimination. The only way you can change a system to produce something equivalent is by multiplication of either one equation or both equations, depending on how much you need to do. So we're going to eliminate, or we're going to change the system by multiplying one or both equations by numbers so that either the x or the y terms will be the same or opposite. All the terms in the equation get multiplied by whatever you decide to multiply by to make that work. So you may want to make your x's match, and it may require you to multiply by 2 to do that. But everything in the equation multiplies by 2, not just the x term, because you have to create an equivalent equation. And to do that, what happens on one side has to happen on the other side. Everything gets multiplied by that. You can choose which variable you want to eliminate. Sometimes you're going to see one that's going to be significantly easier to eliminate than the other. Sometimes it may be just as easy to eliminate one as the other, and it'll just be completely your choice. So you look at that, decide which one you're going to eliminate, and then do whatever is necessary to be able to make that happen. Again, sometimes you might only have to multiply one equation. Other times you may have to multiply both. And so we're going to look at examples of both of those situations just so that you understand how that works and when. So, take a look at this one. Here we have a negative 4x, positive 9y, and a 9. And then we have an x, a negative 3y, and a negative 6. You'll notice when you look at that the x's don't match, the y's don't match. And so at this point, there's nothing that I can eliminate. So when you run into that situation, you want to look at your smaller, or your terms with the smaller coefficients, and see if there's a way to multiply that to make it turn into the one with the bigger coefficient. And if there is, that's what you're going to multiply by. If there's not, it may be a situation where you have to multiply both. So when I look at this bottom equation has the smaller coefficient. So I'm going to look at how to change this so that something will match with what's up here. So my x is currently a 1. I can make it into a 4 so that it can cancel with the 4 that's up here by multiplying by 4. That's an option. My y is a 3. I can turn that into a 9 by multiplying by 3 so it can cancel with the 9 that's up here. So that's also an option. In this situation, it's going to be equally easy for me to eliminate x or y because multiplying by 4 or multiplying by 3 is really pretty much the same thing. It's the same amount of work. So it's really completely my choice on which one of these I'm going to change. So just for the sake of doing it, I'm going to choose to change the y. So I'm going to... Oops. Somehow I clicked off, sorry. I'm going to make the y's match by multiplying this entire equation by 3. Because if I multiply by 3, my y will turn into a 9. So I'm going to basically do distributive property with that 3. So I get 3x, negative 9y, and negative 18. So 3 times x is 3x, 3 times negative 3 is negative 9, 3 times negative 6 is negative 18. Once I do that, I no longer need the original equation that I had. So I usually just come along and kind of cross it out. You might want to just rewrite your system over to the side if you prefer to do that. But I usually just come through here and kind of cross that out and go with what I've got left. So now I have y's that match. I have a positive 9y here and a negative 9y right here, which means I'm going to eliminate the y. And because they're opposites, I'm going to add to do it. So they're opposites because I have a positive and a negative one. So I'm going to do addition to eliminate that. Again, we're just adding straight down the thing. So negative 4x plus positive 3x gives me negative 1x. A 9 plus a negative 9 cancels out. 9 plus negative 18 is negative 9. And then I can finish this by dividing by negative 1. So x will equal positive 9. Now, the second step is the same as the second step has been. The only thing that changed about the way these work versus the way the other ones work is that we had to take that extra step of multiplying. So I can take that 9 and I can plug it into any of the equations that I've created here. So really, that equation that I changed is probably the simplest of the equations. So I'm going to go and plug into that. You could have plugged into the 4x plus 9y equals 9. You could also plug into that new equation, 3x minus 9y equals negative 18. All of them are going to give you the right answer. But it's entirely your choice on which one to plug into. So x is 9. I'm going to come over here and take the x out, replace it with a 9. And then I'm going to solve this. So I can subtract the 9. I get negative 3y on this side. Over here I have negative 15 divided by negative 3. And y will equal 5. So my solution here is 9, 5. All right, let's take a look at another one. Here I have a negative 4x and an x. They don't match. And then I have a negative 15y and a 5y. They don't match. So I've got to change this into something that will. Again, entirely my choice, but you want to kind of go with whatever's the easiest to do. So I can change a 1 into a 4 by multiplying by 4. I can change a 5 into a 15 by multiplying by 3. Both are about the same amount of work. So it doesn't matter to me which one you choose to do. Entirely your option on that. I'm going to multiply by 3 and cancel the y. So it'll give me a negative 3x, a positive 15y, into negative 39. Once I've changed that equation, I no longer need the original. Take it out. And now I'm going to eliminate my y. I have a negative 15 and a positive 15, so they're opposites. Because they're opposites, we're going to add. And so I'll add everything here to eliminate. Negative 4 plus negative 3 is negative 7x. My y's are gone. Negative 17 plus negative 39 is going to be negative 56. And then we can finish that out with division. And so x will equal positive 8. And again, once I know what x is, I'm just going to sub that back into one of the original problems. I'll just go with the top this time. Negative 4x minus 15y equals negative 17. 8 is going to go in place of x because it is what x equals. And now solve that. Negative 4 times 8 is negative 32. That means I can add 32 on both sides. And that's going to give me a positive 15. And then I'll divide by that. Or divide by negative 15. And y will equal 1. Sorry, I didn't really leave you enough space for that. Or else I wrote too big. Oh, negative 1. I said 1, but I meant negative 1. Sorry. All right. Take a look at this one. So in this one, we have a 5x and a 3x and a 4 and a 6. None of that can eliminate the way it's written. But also, I can't turn a 3 into a 5 by multiplication. Not by a whole number anyway. I can't turn a 4 into a 6 by multiplication by a whole number. So this is a situation where we're going to have to multiply both equations to eliminate something. So I have options here. If I look at 3 and 5, I know that I can multiply 3 and 5 both by numbers and turn them into a 15. That's the least common multiple for those. For 4 and 6, the least common multiple is 12. 4 times 3 is 12, 6 times 2 is 12. But I also could do like 4 times 6 and 6 times 4 and turn them both into 24s, and that would work too. So there's a lot of things we could multiply by that would allow this to cancel. It's entirely up to you which one you choose to do. You just need to make sure you're turning them both into things that match so you can do the elimination method with it. So because I think it's a little easier to change 5 and 3 into 15s, I'm going to go with that. I don't know why I think that's easier. I'm just rolling with it. So to turn a 5 to a 15, I'd multiply by 3. To turn a 3 into a 15, I'd multiply by 5. You may notice that I multiplied on top by the number from the bottom, and I multiplied on the bottom by the number from the top. I did, and that will work every single time. So if you have no idea what to multiply by, that strategy always works. So now I'm going to change the system by multiplying by the 3. Since I have to change everything, I'm just going to come out here to the side to write my new equation. So I have 15x plus 12y equals negative 42. And then on the bottom, I'll do 5 times 3x, 5 times 6, 5 times 6. So I get 15x, 30y, and 30. And so when I look at this, now my x's match. I can eliminate them. So they're exactly the same. Signs are the same, numbers are the same. So because they're the same, we're going to eliminate them with subtraction, which means everything here gets subtracted. 12 minus 30 is negative 18y. Negative 42 minus 30 is negative 72. And I can finish that out by dividing by negative 18. And that'll tell me that y equals 4. Oh, I eliminated the x through subtraction. So now I have to put that 4 back into one of the equations. You can put it back into one of the original equations. you can put it back into one of your new equations. Either option or any of those options will give you a correct answer as long as you do the math correctly when you work it. So I'm going to just put it back into the second of the originals because this is probably the simplest looking equation in my opinion. So 3x plus 6y equals 6. I now know that y is 4, so where the y is, I'm going to take it out, put a 4 in that spot, and I'm going to solve that. So 6 times 4 is 24. Then I can subtract 24 off both sides. 6 minus 24 is negative 18. This side is still 3x divided by 3. And x is negative 6. So those are a little bit tougher. Just have to remember how to change them by multiplying everything in them. All right, one more together and let y'all try the last two. So this one we're trying to get something to match as well. The way that it's written now, I have a 7 and a 4 and an 8 and a 9. None of that matches. So I'm going to have to multiply both again. I can either make a 7 and a 4 become a 28, or I can make 8 and 9 become 72s. Either way is okay. I'm going to say that maybe multiplying by 4 and 7 is going to be a little easier than multiplying by 8 and 9, so I'm just going to go with that. So I'll multiply the top by 4 and the bottom by 7. So that's going to give me a negative 28x, a negative 32y, and a positive 36. And on the bottom, I'll get negative 28x, positive 63y, and what is 22 times 7? 154. So negative 154. Now I'm ready to eliminate. So my x's match. They're exactly the same, which means I'll eliminate them through subtraction. And so this part is the thing that we're eliminating. We'll subtract that. It goes away. Negative 32 minus 63 is going to be negative 95. Y. And then 36 minus negative 154 is going to be 190. So when I go and do that division with that, divided by negative 95, divided by negative 95, I'm going to find that y is equal to negative 2. Okay, so I know my y is negative 2. I'm going to go plug that back into one of the original equations. It doesn't matter which one. So I'm going to go to negative 4x plus 9y equals negative 22. And now where the y is, I'm taking it out, putting a negative 2 in its spot. And so I have negative 4x, negative 18 when I multiply that, negative 22. So I'll add the 18 on both sides. So I have negative 4x on this side, and over here I'll have negative 4. And then when I divide that out, I find that x is equal to 1. So the point 1, negative 2 is our solution to that. All right, just like last time, take a minute, pause the video, and I'd like you to work the next 2 slides, the 2 that say you try it. And then once you finish, come back and see if you were able to get correct answers to both. So go ahead and pause the video, work both of them out, and then come back. Okay, take a look at this one. See if you were able to come up with an answer of negative 2, negative 4. If you didn't, pause the video and look over my work and see if you can see what you did wrong. You may have forgotten to multiply something. You may have done the wrong operation, like added when you should have subtracted, something like that. All right, on the next one, you should have gotten an answer of 2, negative 5. And again, if you didn't get that, see if you can take a look at what maybe went wrong so you can see where your mistakes happened there. All right, that is the end of our video. You can go ahead and submit these notes and then start working on the practice. Have a great day.